In this video, we're going to talk about section 9a, which is the first section in our study of functions. So before we really talk about what a function is, we first need to define a variable. And for this class, we define a variable just to be a quantity whose value can change. And if something's changing, that means it's varying. And that's really where we get the word variable from. Its base word is vary. So a variable is something that changes. And an example of this is the cost of a gallon of gas. It seems like every single time you drive by a gas station, the cost of a gallon of gas is different. It can be different from morning to the afternoon. And it changes based on a variety of factors and variables, but it is something that varies based on time of day or what's going on in the world. So when we're studying functions, what we're talking about is some type of mathematical representation that relates two variables together. So it's going to describe how when one thing changes, it affects the other thing. So the thing that's doing the changing we typically call the input, and then the thing that's showing a response to it we typically call the output. And we're going to relate those words together more in about 2 more slides. But a function is just a mathematical relationship between two quantitative values that are changing. And what's really important is that whatever goes into the function, one and only one thing can come out of it. So we say that each input has exactly one output. And in this class, we don't talk about the vertical line test formally, but many of you maybe have seen it in a previous math class. So if that rings a bell, that's what we're talking about. If it doesn't, don't worry about it. In this class, it's not one of our learning objectives. So there's a lot of different ways to represent a function. You can represent a function using words, or tables, or sets of ordered pairs, or graphs, or mathematically with equations, and there's many, many more. And in this class, we're going to pretty much use all of these. So there's lots of ways that we can represent functions. So let's talk terminology more, because that's really the focus of this section. I said earlier we've got input and output, and there's a bunch of different ways we can describe this. So the input is typically what goes into the function, and the output is what comes out of it. Often, the input is referred to as the independent variable, and the output is the dependent variable. And I like that dependent because that's showing that it depends on something else. The dependent variable's value is going to be based on whatever the independent variable was. So the independent kind of does its own thing, and the dependent variable shows a response to it. Typically, we represent the independent variable by either the letter X or the letter T. And then we represent the output, the dependent variable, by either Y. Often you'll see like Y equals 2x plus 5, or sometimes we use function notation using like f of x or f of t. And we'll see a variety of letters as we go forward. On a graph, the input is represented by the horizontal axis, so the axis that goes across the bottom. And the output is typically represented by the vertical axis, so it goes up the side. If we're using a table, then the input is typically the top row of the table, and the output is typically the bottom row. Or if our table's in columns, the input is the left column, and the output is the right column. So if you're thinking about reading, in English we read left to right from top to bottom. So the input's always what comes first. It's either on the left side or it's on the top, whichever one you come to first. If we're talking about an ordered pair, then the input is the first coordinate and the output is the second coordinate. And this will be a useful slide to come back to as we're looking at functions in different forms so you can reference what's what. So really the section of 9a is just to practice identifying what's the input and what's the output in a scenario. Which variable determines the other. So here's an example. We want to look at poking a smoke will always result in the emission of noxious and toxic fumes. Well, there's 2 things going on here. One item is that somebody is poking a skunk, and the other item is that there are toxic fumes being emitted. So you want to ask yourself, all right, I've got my 2 things going on, which one determines the other? Does toxic fumes make somebody poke the skunk? Or does poking a skunk cause the skunk to release the fumes? And hopefully we all know that it's poking the skunk results in the skunk releasing toxic fumes as its defense mechanism. So we would say our input is the poking, maybe how often or how hard you poke the skunk. I don't know how we're measuring it, but you poke it. That's kind of what you can control. And then the result or the output is the toxic fumes. So our independent variable is poking. Our dependent variable is the release of fumes. Another example, maybe a little bit more mathematical. If leaf color change is related to temperature, then exposing plants to low temperatures will result in changes in leaf color. So again, we've got two things going on here. We've got low temperatures and we have the leaves changing colors. So again, you've got to ask yourself, does low temperatures cause the leaves to change colors? Or do the leaves changing colors cause it to get colder? And in this example, it's the low temperatures that cause the changes in leaf colors. So we say the temperature is our independent variable and the change in color is our dependent variable. The temperature affects the colors.